Great. Well, thank you very much for joining. As you can see, I'm not Matt Brown. I'm pretending to be Matt today, so he's on PTO. Apologies for the slight hiccup there. And so, but we'll get started very shortly. So thank you very much for joining. And my name is Akmal Chowdhury, and so today our presenter is Alex Peng. So Alex is going to talk about LangChain for multimodal apps, chat with text image data. And so one of the things that we see in recent times, this kind of interest in being able to develop applications that can do more than just work with text, video, audio, for example. And in fact, I think Facebook released something very recently that can handle all of these together in one environment, which I'm actually looking at and evaluating at this very time. So Alex will talk us through this. Alex, next slide, please. Okay, so as you know, we run a series of webinars on a regular basis each week. And so here is the next one for January 29th, build real-time document image analytics with GPT-4 vision. So that, again, I think probably overlaps a little bit in terms of today's area, though I think Alex is going to talk about something slightly different there. So if you're interested, please do scan that QR code, take the opportunity for the tiny URL there in the bottom left-hand side, and register for that. Next slide, please, Alex. There we go. So we always have this AirPods competition, okay? So I'm not sure who's going to announce the winner, but we'll see. Matt may be able to join us. Hopefully he will. But again, QR code and the tiny URL there. So typically what we do here is that if you follow that link, you'll get to the sign up page for the SingleStore DB Cloud, and take the opportunity to create an account, which literally you can do in like less than a minute. Seriously, I mean, it just requires your user ID and password, or you could choose to use Google or Microsoft to create that account. If you already have an account, log in, and I think we'll track to see who actually logs in and use one of those to be able to enter into the draw. Okay, so take your time with that one as well. And Alex, if you could just ensure that those slides are shared with me, what I can do is take those tiny URLs to leave you to focus on the slides themselves, and then I can take those and post them into the chat as well, so that people who are not able to take those now, maybe joining as we speak, can grab those a little bit later on. Okay, great. Well, thank you very much. So Alex has been with us for a little while now, and you're at Stanford, I think, aren't you?
I am, yeah.
Oh, awesome. One of the little-known facts about Stanford University is that someone some years ago, and my background is kind of academia, told me that Stanford gets more funding than all the universities in the UK put together. Well, there you go. That's how much money you're worth. So without further ado, let me hand that over to you, Alex. And so I'll drop off now, okay? And as I said before, I'll post the links into the chat there, and I will monitor the questions as well, and then join a little bit later on for the Q&A. There we go. So,
All right. Thanks, Akmal. Funny he mentioned that. I guess we Americans just do it a little bigger on this side of the pond. Okay, so hey everybody. Hi, I'm Alex. I'm a growth engineer here at SingleStore. Sorry about the kind of delay on starting the webinar here, but let's just jump right into things. We'll have time for, a short presentation, a live code demo, and then hopefully some time for Q&A. So jumping just right into things, let's talk a little bit about this emerging architecture that we're seeing for LLM applications. And specifically, let's think a bit about retrieval augmented generation. So for probably most of you, retrieval augmented generation at this point is a term very familiar to you. LLMs, as we know, are very powerful and able to reason over out of distribution data, generally pretty well. But what happens when you have an LLM that isn't actually trained on the data or information that you're actually interested in? Say, for example, your SingleStore, and we just built out a new chatbot called Squirrel, which is fine-tuned on our documentation, using a LLM like GPT 3.5 or ChatGPT. That LLM would not know anything about SingleStore's documentation, or at least not in specifics. And so that's why we need this kind of paradigm, retrieval augmented generation. And this diagram shows it pretty well, but essentially what we're doing in retrieval augmented generation is we are supplying the LLM with information that it uses to formulate a response that's grounded in truth and not hallucinated, right? So when we're using retrieval augmented generation, I'll just call it RAG from this point on. We need somewhere to store this data that we end up supplying to the LLM. So this sort of architecture diagram shows, at a very high level how that works. At the front end, we have the UI, then we have API endpoints that connect us into a contextual data store. In our case, that's going to be SingleStore, and that's what actually stores your vectorized data, which the AI is able to query and then prompt with. And we'll get a little more into that in a bit. Just zooming a little bit into the contextual data layer, this is kind of just a very high-level overview of what SingleStore is able to do. It's able to store both structured and unstructured data. So you can see all the different types of data here: Slack, PDF, CSVs. You can store, table format data in SQL. You can query in SQL, and you also kind of get a layer of you also get a governance layer that allows you to kind of define user permissions and user access and data access policies, across your kind of data lake. So some things to consider for vectorization, which I just mentioned. Vectorization is essentially the process of converting data. So for example, a PDF or an image into a LLM readable format that an LLM is able to search over at a later time. It's a kind of one-time process. So anything that you're going to be using for real-time contextualization, text, images, videos, audio, you're going to want to vectorize so that the LLM is able to find relevant information when a user does prompt them later, and so the LLM is able to give grounded, truthful information. I'm going to speed through this because I really want to get to some of our exciting demo today, and then also leave some time for Q&A. We've seen just an explosion of multimodal capabilities. It's probably the reason why you joined this webinar today. Multimodal LLMs are the key concept and trend to kind of recognize for LLMs in 2024, right? We are seeing just an absolute kind of exponential takeoff of the capabilities of LLMs in reasoning over image data, over audio data, over video data, right? Allowing you to, say for example, chat with an image or chat with an audio file or a video. If you've played with ChatGPT, if you have a GPT-4 subscription, you might have played with this recently, noticing that you're able to now paste in images into your chat box, and actually the LLM is able to understand the content of the image. When we have multimodal, data formats, we actually need multimodal embeddings as well. Embeddings is just another term for vectorization, which is what we just covered earlier. This is just a few examples of embedding models that allow us to vectorize, say for example, image data or text data or audio data. But we actually need, a multimodal specific embedding model so that an LLM is able to search over a wide variety of data, not just text, for example, which is what LLMs have mainly been focused on over the last year and a half or so. And then once we do have multimodal data, obviously, multimodal LLMs are required to actually reason over that data once we've, retrieved it from our, contextual data store. So, just this list of options is, very fast growing. Obviously, at the forefront, we have OpenAI's GPT-4 vision model, which powers, the ChatGPT image reasoning. We also have open source models, which have come out very recently, and are providing, very comparable performance to OpenAI's GPT-4 vision model, sometimes even surpassing it in fine-tuned use cases. And happy to dive into that in the Q&A for much less compute cost. In some cases, you can even run it directly on your computer. And the key question to answer here is going to be, how complex is your task when you're actually selecting a multimodal LLM? You don't really want to overkill by, having GPT-4 vision, maybe just like read out some text from an image. But, if you're using a smaller model, it might not be able to, understand more complex relationships between objects in the image or causal relationships, that sort of thing. So what is SingleStore? SingleStore, very, very quickly, is a database to transact, analyze, and contextualize data in real time. This is just some more about us, about some of the customers that we've had, some metrics and testimonials. And I'm going to skip over this. But this is actually a pretty exciting development. We've just recently started rolling out a web-based Jupyter notebook, SingleStore notebooks, which is, I think, a really exciting feature. Our demo today is actually going to be in SingleStore notebooks, and the really powerful feature of SingleStore notebooks is that it connects directly inside of the SingleStore web portal, connects directly to your database. Actually, we just announced at SingleStore Pro Max that SingleStore notebooks now have access to compute. So I think on our free tier, there's like CPU and GPU compute, very similar to Google Colab for those that have used that before. So you're able to kind of maybe even try running a local LLM or fine-tuning a small model and seeing, if the SingleStore notebooks use case or if those capabilities work for your use cases. So let's get ahead here. LangChain. So we're going to be using the LangChain framework today. LangChain is a library for orchestrating LLMs. SingleStore is integrated into LangChain, and that's what we'll be using today, the SingleStore integration in LangChain, to build an end-to-end image understanding app or flow that uses SingleStore to store image captions, and then later prompts GPT-4 with that image data. So let's go ahead and just jump into it. All right. And I see we have some questions here. So I think Akmal can field a few of those, but also we'll have time for me to get to them at the end. All right, let me just pause here. All right. Okay, great. So the first thing you're going to want to do, if you've already opened up the AirPods sign up link, then you've already seen this page. But what we're going to do is we're going to sign up for a SingleStore account. Actually, we just announced there's a new SingleStore free shared tier. So if you start an account today, you can start with our shared tier and then also get $600 in credits to start a SingleStore account. But once you do have a SingleStore account and you've kind of gotten past the sign up stage, what you're going to want to do is you're going to be in the SingleStore web portal here, and you're going to want to start a new workspace. So I already have a workspace set up here, but just to show everyone what that kind of flow looks like, when you're creating a new workspace, you're going to define, the workspace name. You can, define the cloud. We're multi-cloud, so we're on AWS, Azure, and GCP. You can define, how much RAM and compute you'd like your space to have for your queries. And then you create your workspace. And then once you've created your workspace, you'll want to hook up a database to it. And once so hooking up a database to it is as simple as just clicking this create database button, naming your database and then connecting it to your workspace. And once you've had a database connected to a workspace, there's a few details you do need to note down. You're going to click this connect button so that you can get some API access to your workspace. And then the first time you open this, you're actually going to see the workspace password. And you're also going to see here just a few of the workspace details that are important for you to note down. Actually, now that I'm thinking of this actually is a pretty good segue into the next part. But once you have all this data, you can go ahead and throw it away, actually, because inside of SingleStore notebooks, like I mentioned earlier, you actually have access to the entire database from just within the notebook. And so the database details are actually all populated for you inside of the notebook. As long as you're running inside the notebook, all the details are populated for you. So the only thing you do need to note here as we start going through the code is for the LangChain integration with SingleStore, you do need to define the SingleStore database URL, but that's all in the code, and the code will be shared with everyone at the end of the webinar. But anyway, just jumping right into the code, what are we going to do here today? We're going to be taking image data. So I have just some photographs, some portrait photos from the Library of Congress, which we are going to store captions of with a image captioning model inside of SingleStore. And then we're going to retrieve images, the most relevant images for us based on those captions. And then finally, we're going to prompt OpenAI's GPT-4 vision model with those retrieved images and a user query. So let's take a look here. Obviously, we're going to want to import SingleStore database so that we can store our image caption embeddings. Just side note here, you can also store the images directly into SingleStore. That's a little outside of the scope of this. And I think we are ramping up support for image storage inside of SingleStore. But you can encode an image as a base64 string and then store that actually directly inside of SingleStore. And you'll see, if you don't understand what that means, you'll see how all those pieces kind of fit together later on. So after you've imported the SingleStore vector store, we're using OpenAI today, but so you'll need an OpenAI API key. But if you'd like to use an open source model and maybe try out some of our new compute abilities, you can also do that. So some of those open source models that I mentioned earlier, those would be good options here. So this is just downloading the image to the workspace. And then what we're doing here with this image caption loader, which is a LangChain document loader, is it basically is taking all of our downloaded images and then running an image captioning model, which basically just looks at the image and puts out a sentence describing that image. And then what we're doing is we're storing those captions inside of a list of documents, which also stores as metadata the path to the image. So once we have all those image captions, the You can look at the image caption loader docs for some more details on the actual captioning model, but for now, just for the sake of time, we'll kind of skip past that. Once you've gotten the list of documents, and the documents kind of look like this, it's just sort of the content of the document is, a short description of the image. Here's the image in question, just so everyone can see. It's a very famous photograph. Oops. Very famous photograph from the Depression era, I believe. This is the picture in question. The image captioning model has now captioned it. We have the image path as metadata, and now we can really get into the meat of things. So within LangChain, what we're going to do is we're going to define, a number of different functions that are basically going to build out our prompt to OpenAI. Because with multimodal LLMs, we're not just going to be prompting with, a sentence or something like that. We're actually going to be prompting with an image. And there's actually a specific way that we have to prompt OpenAI with images. And so we're going to get into that right now. So just a few different functions that we've defined here. This is a really important one, encode image base 64. That basically takes an image path. So, our metadata here, and it encodes it as base 64. And base 64 is basically just a format, 64 characters long for storing data. And so once we've encoded our images as base 64, we actually need to build out our prompt. So we just kind of append our messages into an overall message into OpenAI. There's some kind of formatting that we need to do. We insert our base 64 formatted, version of our image. And then finally, what we do is we'll retrieve the most relevant content from our vector store, in this case, SingleStore, build out that prompt. And then at the end of it all, what we're going to do is return the response. So, whoa, okay, that's a doozy. I know I just kind of sped through all of that, but that's really to try to get as much time as possible for questions, which I'm sure there will be a lot of. But let's break this down step by step. We have a retriever, and then also, our chain, which is our LangChain RAG chain, which is basically building out, step by step what we need to do in order to return those images, or to pass those images to OpenAI and then get a coherent response. So in the retriever, what we can actually do this just piece by piece. In the retriever, we give the retriever a query, like, show me portrait pictures and describe them as an expert photographer. The retriever is going to actually be going through our vectorized data, comparing it to our query, and trying to get us documents that it thinks are going to be the most relevant to us, and that are going to actually answer, the user's question. So after you kind of run that query, you're going to get, a list of retrieved documents from the retriever. And that's just that same image that we showed before. And then let's see. Ooh, we might have to see the output of this. We might have to go to this here. Let's go to SingleStore Labs. This is where our code example is going to live, by the way. So everyone should have access to this link. Oh, okay. Well, there's no output right now because it's just going to take a bit to install the packages and actually show the outputs. Actually, let me see if I can just run that in the background while we're waiting. But let's go ahead and let's look at some of these questions. Akmal, any questions that came up or any themes of questions that came up that would be good to start getting into while I'm just running the code
Yeah,
here?
so people asking about your code, and you've already mentioned, Alex, that you're going to share this anyway. So the notebook, and we usually, I think on our GitHub repo there is a couple of places out there, but you're going to put it up on Spaces. That's where they tend to end up mostly now, don't they?
Yeah.
Hopefully.
It's gonna be on Spaces as well. Yeah.
Okay.
It's so we have the Python notebook on SingleStore Labs, and it's gonna be on Spaces too. Yeah.
Right. So I think that was the main one. Okay, got a question here from Steve asking, what is Spaces? Great question, Steve. Let me find the link, okay? And I think it's just as simple as singlestore.com/spaces. I think if I'm good to go, and you can actually access that from within the cloud environment as well. There we go. There. So thank you for that, Steve. So let me just post that there for you. There we go. Okay, so essentially what we try to do with Spaces is typically for a lot of these webinars, we, as the requests come in, it's a good idea to put them in a standard place where people can access them. And rather than just sticking them up on the GitHub somewhere, Spaces is a great place because you can access that directly from the link, or once you're in the kind of cloud space, you've provisioned some resources, or as the free tier, as Alex was saying, you're using that, then you can easily access this content as well directly, which makes your lives easier. You don't have to hunt around and search for this stuff. I think that was the main one. I think let me just see if there's any other interesting questions. So yes, some again requests for the GitHub link. Yes, so the links will all be posted out. Okay, so the resources, links to Alex's notebook, Spaces, all of this, we'll send this out later. Let's have a look. Alex kind of said, there's a question there, says, anonymous, tokenization of images and sending it to OpenAI GPT, question mark, to generate captions on it?
Could you repeat that question?
Yes, so the question is anonymous. It says, tokenization of images and sending it to OpenAI GPT, question mark, and then subsequent sort of question, to generate captions on it, question mark.
Okay, so if I'm just understanding the question correctly, what we're doing for image caption generation, which I'll just scroll to here,
Yeah.
is we're using this LangChain document loader, which uses, I believe it's called like blip image captioning. It's a different model, which basically just takes a given image and generates a short caption for it. And then that's what we end up storing in this example, at least. That's what we end up storing in the database.
Okay. Okay, so got a question here from Rosalind. Is it possible for us to use in Visual Basic? I assume some of those techniques that you've described should be possible, I'm guessing.
I don't believe that LangChain has support in Visual Basic. I think it's just
Right, but are there
Python and
alternatives,
TypeScript.
for
Go ahead.
example? Yeah. I was just going to say, are there alternatives? I mean, could we use something else? You've obviously used LangChain here, but do you think there's another way we could do this, if not directly through?
Yes. So not off the I don't know off the top of my head, but like, in
Yeah.
principle, I don't think it's impossible.
Yeah, so essentially we'll check that. So Rosalind, well, thanks for the question. A great question, actually. I think people don't quite realize how popular Visual Basic still is. A lot of people do use it in production environments. So we'll dig into that bit for you. Let's see. Okay, so there's a great question here from Stian, who says, can you make an app notebook on local PC and connect to a notebook on SingleStore? I run the notebook on SingleStore from a local app notebook in VS Code. I guess, well, let me make an attempt to answer that. So I kind of done something similar. So I often use a virtual machine for a lot of sort of Linux type stuff, libraries, and then the benefit of the virtual machine is taking snapshots as well, and it leaves my host environment, which is a Mac, untouched. Otherwise, I end up with problems where lots of incompatibilities and things with software. So in the virtual machine, I use Jupyter. And there, yes, it can run the notebook. And if you configure it and set it up correctly, you can connect to SingleStore. And depending upon what you're using, which version of the SQL Alchemy, for example, it should be possible to do mostly um, the things that you can see Alex doing, but perhaps not everything. I know I've come unstuck in the past with the local environment. I think it all depends on the SQL Alchemy. So within the version that we have in the cloud, it's configured and designed specifically for our environment, and it's pretty good and it's supported. But you may well be able to get away with some elements of that. So remember, SingleStore is MySQL compatible, but there are some differences as well. So that is, I think, you know, not quite a yes no answer. It's more of a grayscale there. Let's have a look. All right, so here's a good question, Alex. Maybe you got some thoughts on this. So Nani asks, are there any limitations to vector databases compared to traditional ones?
Yeah, so actually that's a big reason why we at SingleStore think it's makes much more sense to unify your data under one platform, right? So, a lot of these existing vector databases or new vector databases are coming out like Pinecone, Weaviate, Qdrant. You kind of have to decide what data gets vectorized, what doesn't. And on top of that, define new data access policies. You kind of have the headache of managing data across multiple platforms. And we believe that, if you have a relational database already and it supports JSON, why not just have your vector database also be your normal database, and have all your data and also compute very close to each other. And that way you can get real-time performance. You can get like millisecond query performance. Yeah, not sure if that answers the question, but that's the kind of high level how I think about things. And
Okay,
Akmal,
so
feel free to add
yeah, that's
anything on
great,
yours.
Alex. Yeah, so Averell has posted a comment here. He says, I've used LangChain in VS Code. Good to know. It's great, when people share their experience, and this is, adds to knowledge. Thank you very much for that. That's a great help, I think, for other people maybe asking the same question. Let's have a look. What else? What other questions have we got? And let's see. Okay, so here's a great question from Vimal. I might be able to answer this, Alex. So he's asking, can you tell me, Matt? Okay, so I'm really Akmal, but I'm pretending to be Matt. So I'm using his account. Why we are storing vectors in external systems for this kind of an application based on LLMs, and why do we need to do some mapping of those to SingleStore? Well, actually, as Alex was saying, I mean, some support, for images, for example, it has to be converted into a format that SingleStore can work with. And so base 64 is pretty well known, fairly standard. And I know that I've worked with other data types in the past. So when I started working for SingleStore about over 2.5 years ago, some of the early content that I worked on was, for example, looking at, say, a movie recommender system. And as part of that, I might be interested in storing the actual images of posters for movies, for example, as part of the information that I hold within my database system. And so it's great to find a mechanism to encode that, have a representation then can be stored directly in the database system. Now, of course, you kind of have to do the reverse, okay? If you want to visualize it, build a front end, do the reverse operation, effectively work backwards and derive what the image is. But that's easily done. I mean, what is code for and what is a database for? I mean, they do the number crunching and the hard work for you. But I think generally with the vector support that SingleStore has, for example, and the announcement that we just made a couple of days ago, in fact, on Wednesday, was a dedicated vector type, plus indexing for approximate nearest neighbor, and lots of different options for that as well. So essentially now you can store your vectors directly in the database system, but you do need to generate them from somewhere. Okay, so you saw Alex using a couple of technologies there. You could equally, you could use another LLM, you could use Cohere, for example, or you could use some other way to be able to represent that as a set of numbers that will give you some information about what you've actually stored. So, and that's readily done. And so what is a vector? It's just an array, yeah? Just numbers. So you don't have to store it externally. There may be cases where you're working with external systems, for example, where you're reading them in. And actually, someone was asking me a question earlier today saying, well, look, let's say I've got some vectors stored in a MongoDB environment, and then I use the change data capture tool to connect to that from SingleStore, and then I'm reading that data into the SingleStore environment. What about the vectors? Well, if they're part of the JSON document, they will come along as well, okay? You get exactly the same representation of those that you had in one environment as you do in SingleStore. And then you should be able to utilize those. But of course, you need to know how you derive those and how those vectors were generated to use the appropriate techniques there to kind of understand, okay, what it is you've got.
Hey, Akmal, I actually wanted to chime in here because I know I left everyone on the edge of their seats because I didn't show the actual live demo working. So I just I'll show a little live debugging of how we actually got it all up and running. Just I don't know if anyone saw earlier, but we got a bit of a strange arcane error, leaf error node, argument sizes don't match. And that was just because I was playing around with a different embedding model earlier. But what I did to fix that was basically just change the embedding model back to the original embedding model, which I had been using to set up this demo, which is this open clip embeddings model, which basically takes the open clip multimodal embedding model that we just talked about and embeds actually both the image and the text query that you end up querying the retriever with. So just to get right back to where I was when I left off, when you send this query, you'll get those documents and you can, see the retrieved document, which in this case, it's just one picture, but you can hopefully it's obvious how you can scale this up to many, many pictures and many, many chunks of text. And then I just showed everyone when you actually run the query, which is, describe this picture to me as an expert photographer, you see, OpenAI actually is able to understand the composition of the photo, the subjects in the photo, the positioning of the subjects in the photo. And so this is, the full demo and working end to end. Happy to field more questions if those come up. We do have only a few minutes left.
Yeah. Alex, is that when you mentioned clip, is that the OpenAI clip? Is that the open source version on GitHub?
Yeah, it is. It is. It's
okay.
Actually, that's what makes LangChain really, in my opinion, really convenient to use. It's they just have an open clip embeddings library, and don't worry about this OpenAI API key. It's just a dummy key that we're using right now for anyone that might be, having an aneurysm because of that.
And generally, I think GitHub is good. It will warn you if you leave any of these in your notebook. It will tell you you've got something that you need to take out. Okay, great. So let's just try and find a couple of other questions. Okay, there's a question from Abrar Sharif here. He says, is it possible to build a chatbot just like the Squirrel? I think that is what you meant, Abrar, from SingleStore, from only open source models. So essentially just interested in Squirrel. So I think with Squirrel, we had to work with an external company to help us to build that, I believe. But if you just wanted to use just purely open source technology, yes, I'm sure you could do something similar. plenty of great open source technology out there. Let's have a look. What else?
Oh,
We
just to
have.
add on a little bit,
Yeah.
it's actually pretty simple with LangChain to set up. I know there's some templates in LangChain to set up basically a single store based chatbot that has, in its vector database, just a vectorized version of all the documents or private information that you're interested in, an LLM understanding, and then building a very kind of simple chatbot interface over that. So, would recommend looking at the LangChain docs for that.
Okay, here's a great question again from Steve, asking, LangChain libraries are available in both Python and JavaScript. Might some projects that does this with Java? Steve, I can say to you that a little while back, actually, I looked into Java as well. And I think at that time, and I don't know if it's changed because I haven't looked at it subsequently, but Java is kind of one of these community supported. Let me put it that way. I think it was originally listed as that on the OpenAI website. But I was able to get it working, and I actually wrote a blog post about it. So it's very straightforward to do once you know how. But I'm guessing that over time, probably, there's going to be better language support as well in terms, think about Java. I mean, it's still very widely used in enterprise environments and still one of the most popular languages there. So it's a great question. This is, I think, something that you have to ask OpenAI if that is the LLM that you really want to use. Right, let's just see. Any other questions? Okay. Here's a great question, Anonymous. So it says, is SingleStore to be built on top of MongoDB? How does it compare to Solar Lucene? Okay, do you want to take that, Alex, or should I take it?
You can take it, Alkmaar.
Okay, all right. Well, no, it's not built on MongoDB. So keep in mind that SingleStore is a relational database management system, okay? But it has multi-modal capabilities, it's distinct from what Alex was talking about in terms of multi-modal, different thing, okay? So it has support for time series, geospatial, JSON support has been there for some time. We do have something called SingleStore Kai, which again is GA. Okay, so a long time it's been in kind of preview, but just a couple of days ago it's GA. So if you work with MongoDB, for example, SingleStore Kai gives you MongoDB compatibility. And what this means is that SingleStore is both MySQL wire compatible and MongoDB wire compatible. So SingleStore is not built on top of MongoDB. It can be used to augment MongoDB for analytics, for example, or if you wish, it can be used to replace MongoDB entirely through use of SingleStore Kai. And again, just earlier today, I was doing a conference recording, and we talked about this very, very subject about how MongoDB could be complementary, or you could replace it entirely. And we do actually have a lot of material on this as well. Plenty of content on SingleStore Kai. So if you are coming from the Mongo world and you're kind of interested and maybe retain your skills, be able to utilize them with SingleStore, you can do so with SingleStore Kai. So maybe you're working on MERN stack or mean stack apps, you can do that. And that's a great way to kind of transition across to the product. Anything else?
I think we got a very relevant question to us. How does RAG architecture work with any database change streams? Akmal, do you want to take this?
Oh, that's a really hard question. Thanks for that, Alex. Change streams, good one. I mean, the only quick example that comes to mind, my colleague and Arno and I last year at the SingleStore Now conference that was held in San Francisco, I think it was around about October. We did a demo where we were looking at it's network sort of intrusion, people trying to steal your passwords and doing brute force. And there he was generating kind of embeddings, if you like, as the data were kind of coming in. And so that's one case. But specifically beyond that, chain streams, I mean, we support Kafka. So you could read the data in from there, and dynamically, as you're reading the data in, you could create embeddings and be able to store those as well. That might be something to think about.
Yeah,
But it's a
actually,
great question. Great
I
question.
can add on to this
Yeah.
actually. There's a really exciting demo coming out very, very soon on our blog of an LLM recommender app, which is able to embed, new information in real time about, this whole LLM, open source LLM community, new tweets, new posts. It's able to take all these different data sources, embed them in real time using SingleStore, and then give you, when you actually query it, return to you the freshest possible information. So this is actually a really exciting use case that we at SingleStore haven't seen a lot of other vector databases do, which is real-time fresh RAG, live RAG, so to speak. So RAG that is, every time you query it, it's able to basically pull it's able to pull from the most fresh possible source of data. So yeah, if that answers the question at all.
Great. Well, we are at the top of the hour, and again, apologies for the slight delayed start there, but I think Alex was able to cover the key elements of his presentation as well as give you his demo. And it's always great that there's time left over to have a discussion. So kudos to you, Alex. Normally, I think Matt has to force me to stop talking to leave time for questions. So you've done really well there. And so we're almost at the point where we have to end the webinar, but just to announce the winner for the AirPods, and that remember that you get multiple chances for this. Okay, just for this first time. So the winner is Kausik Chattopadhyay, senior software engineer at Fiserv. So well done to you, Kausik. So thank you very much. And there, as I said before, there are other opportunities. So please do create your accounts and log in. And there will be additional opportunities for sort of winning AirPods as well. Okay, they are branded. Sadly, I think SingleStore employees are not eligible. I'd really like to get one of
I
them.
actually asked
Usually, it's
about
people from
this.
Apple that tend to win.
I asked about this, Akmal, and they said no, they can't just give them to us. So
All right. Well, and then strangely enough, I think in the past we've always had people from Apple winning our AirPods, so it's kind of ironic.
yeah, that's right. At SingleStore now, some Apple engineer ended up winning AirPods, and it's like, did this Apple engineer really need them? Probably not.
Okay. Okay, great. So we are a little bit over time, so my apologies for that. So just to clarify a couple of points then. So the link to today's recording, plus Alex's notebook and other resources. There've been some requests that have come in through the Q&A as well. So I'll make the team aware of that. Okay, so we do send out appropriate links to these resources, make your lives easier to get up and started with the kind of things that you're interested in. They will go out as well. Okay, so because you registered for this event, your email will be known, and you will receive a follow-up email, I think within a day or so. Normally there's a little bit of time just to clean up the video and just prepare the email that goes out to the attendees. So please be patient for that, okay? And with that, so it is just gone 7 p.m. my time, so it's the end of my working day and working week. So I wish you well, okay, wherever you are. Have a great weekend, and thank you for joining, and see you again on another one of these webinars sometime soon. Great. Thank you all very much.
Thanks, everyone.